How are you, everybody who is watching this fantastic YouTube channel and the video? My name is Olenjolai from beautifully fantastic, exceptional country in East Africa called the United Republic of Tanzania. I would like to welcome you into this fantastic YouTube channel, which actually the main goals or the main visions is to train advanced students who are pursuing science courses or science programs. We are going to teach you advanced physics, advanced mathematics, advanced chemistry, and even also basic applied mathematics for A-level, from the Form 5 to the Form 6. So almost, I'm going to teach you 8 subjects in total, because 4 subjects for the Form 5 and the 4 subjects for the Form 6. Okay, so believe me that it doesn't mean that I know everything about those subjects, but I know little portions and I'm ready to share with you, because that's the difference between somebody who is gifted and somebody who is not gifted. So I'll be teaching you, I'll be training you, and then we have 3 departments. One of the departments we are in advanced. One of the departments is called advanced physics, and then the main topic is mechanics, and the topic of the day is rotation of a rigid body. Say the rotation of a rigid body. Say rotation of a rigid body. That's the topic we are going to learn today. And then, in case that you feel from your heart that you want to offer your freewheeling Thanksgiving, because we offer this material at the time free of charge, and because the God who has given me this gift and this program and this idea is the one that asked me to do, because I'm solving the national programs or the national problems, okay, which is existing in the United Republic of Tanzania. So in case you want to send you a Thanksgiving offering, this is the number, +255 759 745331. And this is lecture or sessions or period, the festive period. So I would like just also to insist you to do some of the few things in order for you to get connected with the program, that you have to make sure that you subscribe so the YouTube community will give you notification, and we share this material to anybody who is in the United Republic of Tanzania. And as long as you are watching, tell us in the comment sections that you are watching this program from, in which school, in which district, in which regions, in which city, in which, just in each ward, in which village, in which street. Tell us in the comment section so we might know that how far we've gone, because this project is in order to help millions of the students after our current generation and even the future generation. So that's what just I wanted to let you know. So don't get confused. This program, this channel is for the serious students and for the serious, and it is conducted by the serious teacher. And also it is for the serious students. So if you are not serious and you don't want to be transformed into be serious, then this channel is not a suitable place for you. So we are very serious and we are very committed. So even yourself, we ask you to be serious. Follow the instruction that we are going to give you. Follow the reference. Having the reference books and reference materials. Be serious. This is just like we are recording the live lecture that I'm going to. I record it in live lecture by using the digital devices and distribute it across the country and even across the African continent and the world by using the internet. So that's the main goal. So make sure that you have your scientific calculator for computation. Make sure that you have your exercise book, you have a pen, you have all the required resources for you to gain everything that God has prepared or the syllabus is demanding you to cover. So I would like just to take you now into the lecture or into the contents of the lecture. So this is lecture 1. Today I'm going to introduce you with introduction, right? Introductions, okay? In this introduction program or introduction lecture, basically I'm going to share with you some specific objectives, okay? Specific objectives of what? Specific objectives of studying rotational dynamics. Rotational dynamics according to what? According to the syllabus of United Republic of Tanzania, okay, for the secondary education. And then I'm going to share with you the contents that, because I break the topic of rotation of a rigid body, which is one of the longer topic in mechanics. So I will share with you the contents of rotation. Okay? And then after sharing with you the contents of the rotation, and then I'm going to teach you this material, again, that it is targeted, or the class is for the pre-form. So as I say that we are in this lecture 1 or session 1, mainly we are going to focus on these 3 parts. Specific objectives of studying rotational of a rigid body according to the syllabus, and then the contents of rotational, and then I'll be introducing to you the first concept about rigid body and the moment of inertia. So stay tuned. Let us go to the business. So usual, it's a strategy, it's a technique that God has given me that to link or to know what the syllabus is recommending for the students to learn before even they prepare the contents. So in the topic, for example, in previous topics, you find that one topic has also several subtopics. But according to the syllabus of United Republic of Tanzania, that the United Republic of Tanzania Ministry of Education, okay, Ministry of Education, and then it is called Physics Syllabus for Advanced Secondary Education, Form 5 to Form 6. So the topic of rotational dynamics is found in page 10, right? In the 10th page, okay? This is rotation of the bodies. And then these are the specific objectives. These are the learning and teaching strategies. And then you find that it's one of the long topic in mechanics because it is demanding the students to achieve 9 specific objectives. While in case of the circular motion, you find only recommending the students to achieve only 2 specific objectives. So this is recommending 9. So it's one of the longer topic in mechanics, right? So stay tuned. You should be patient. You should tolerate, cut the contents the way it is. So again, it's better for every student. This is my recommendation. I like every student to have this book because it shows you the boundaries of what you should cover. However, that sometimes questions in the exam, they might be just asking you that, or they might be asking you out of the syllabus. But it's better for you to cover what is within the syllabus first. Because the one of the challenge in advanced level is, if we don't have books that have been written specifically like in ordinary level, because you have basic mathematics book, it has been prepared according to our syllabus. So we are using books that have been written by the Indians and sometimes by Americans, you see. So it means that if you don't have the boundaries, you'll be studying everything in physics. And sometimes you might be wasting time because in case of the exam, they don't ask you everything. Okay, so that's the one. So I would like to recommend you to have this book. And because I'm a teacher and also I'm supplying the contents and the knowledge, I also supply this book online. So go to the descriptions below. You'll see the instructions, how you can order this book online. And I will ship it in any regions amongst the 1 regions of United Republic of Tanzania. Take that. No, let us go to business. As I say that, for example, we say that in one of the things that you have to cover, subtopics, right? What are the subtopics of rotational dynamics, okay? Or rotation of the rigid body, okay? According to the syllabus. According to physics syllabus, right? Syllabus for secondary, for advanced secondary schools, or advanced secondary education, right? Education of Form 1 or Form 5, to Form 6 in United Republic of Tanzania, TZ is the abbreviations. So a key point, according to this syllabus, the topic of rotation of the rigid body. So I say that the topic is very important information, my dear student. The topic of rotation of rigid body, topic of rotation of rigid body, right? Rigid body, or bodies, rigid bodies, right? Does not have any subtopic, right? According to the syllabus. Again, another piece of information that I want to share with you. It's better for students to know specific objectives. Why are you learning, okay, rotation of of rigid bodies. Specific objectives. Specific objectives. Specific objectives. Specific objectives. Okay? Specific objectives of a student learning what rotational dynamics, right? Of rotational or rotation. I use rotation dynamics and rotation of rigid body interchangeably. Rotation of 40 of rigid bodies, right? According to, this is not according to me, it's not according to you, this is according to the syllabus. Say syllabus. According to the physics syllabus, right? Physics syllabus, right? For the book is called the physics syllabus for advanced secondary education. And this syllabus is used in secondary education, is used by the students and teachers of the Form 5, to Form 6, right? Where? In Tanzania. So if you are watching me from Kenya, it's better also know the specific objective of rotational of a rigid body according to the Kenyan syllabus, right? If you are watching from Uganda, then don't worry that because I have read the contents from Tanzania, you have to know the specific objective. My finally, they are similar. And that the miracles of God of creating the similarity in education system in the world. So we say that according to them, so let me make a sentence. According to physics syllabus, right? According to this physics syllabus, there are 9 specific objectives. Specific objectives that a student should achieve in rotation of 40, learning rotation of 40 of rigid bodies, right? So what are those? So I will be making a quotation according to this book, fantastic and beautiful book. I'll make a quotation, and because I want to insist you to have this book, I won't mention all the 9 specific objectives. I'll mention some, possibly 4 to 5. So the rest, you should have a book. Yes, you should participate. I'm using the technique which is changing the world right now, which is called active learning. Say active learning. Active learning, that educational system technique that changing the world in the innovation. So you should be active. We are teaching you how to find the resources, the materials in order to solve particular problems. So we say that, let me quote. So whenever you see this means quotation, okay? By the end of what? By the end of this, here it is written subtopic, because this topic goes subtopic, but me I change that by the end of this topic, right? By the end of this topic, the student, you who is learning, should be able to do what? I will mention the first specific objective, to explain. Should be first of all, should be able to explain what? The concept of what? The concept of rotation. Say rotation. The concept of rotation, okay, of what? Of a rigid body. That is the first specific objective. The second specific objective, which is B, I leave the blank, fill the blank. Find this book, fill it. Yes, that's the meaning of active learning. The second specific objective, a student should be able to deduce what? To deduce the radius of gyration. The radius, say radius of gyration. Radius of gyration. I would like to tell you from the beginnings of this topic that rotational dynamics is a beautiful topic of mechanics. Okay, radius of gyration, right? Radius of gyration of a rotating body, rotating body, right? This is, I'm using techniques and the teaching aids that God has trained me, not the school, not the institution that I studied. So this is how God has been preparing me for more than 10 years for this program. So radius, deduce the radius of gyration of rotating rigidity body, right? Rigidity body. And then we go for the first specific objective. I leave the blank, find the book and fill it. Then I go for the fifth specific objective, which is F. Okay? The student should be able to derive expression for kinetic energy. For kinetic energy of a rotating rigid body. So that is the 50 specific objective. And then when you meet all these specific objectives, believe me that you will see the beauty of mechanics, you will see the beauty of rotational dynamics of the rigid body. Believe me. And you will never forget, you love physics. Okay? Physics. Then we go for the sixth specific objective, A, B, C, D, E. This is E. So this is E. A, B, C, D, E. Yes, that is E. And then the next specific objective is F. I leave the blanks. Fill the blanks. Because you're a serious student, you will find this book. You will like it. You will use in your private study. You will use in the class. You will use to challenge your teachers about what they are teaching. But be peaceful, because you're still a student. A, B, C, D, E, F. So this is the sixth specific objective, F, G. Okay? So that you can find these specific objectives in the page. Let me just reference. Means refer page in the page 10 of this syllabus book to page 11. Okay? So the next specific objective, that is G, okay? The student should be able to explain the concept. Oh, fantastic. I like this part. The concept of angular momentum. The concept of angular momentum. I told you the concept of linear momentum in Newton's law. Okay, angular momentum. That is G. And then we go for the specific objective H. I leave the blank. See, the students will fill it. And then we come A, B, C, D, G, H, I. The last specific objective is the ninth. The student should be able to describe. So what you do? Describe the application. Why are we studying rotational dynamics? Why do you want to be a doctor? Why are you studying rotational dynamics? Why are you going to apply it? You're going to be a pharmacist. Where are you going to apply rotational dynamics? So describe the applications of the rotational motion of rigid bodies, right? Of rigid bodies. Okay, rigid bodies in daily life. So that is another specific objectives. So this is the end of quotation. Beautiful. So then those are the specific objectives. If you meet them, believe me that you'll be singing a song called the rotation of a rigid body. You'll have chorus, you'll have bridge, you'll have intro, you'll have outro, you'll have verses, you'll have first verse, second verse. Believe me. So again, after having those specific objectives, and I will be together with you. I will simplify this stuff that look like they're very complex. Okay? I will simplify. I'll use a very simple language. Stay tuned. And then, after knowing all of these specific objectives, I sat down under the presence of God and then developing the contents. So the next part now is I want to present to you the contents, okay, of rotation. The contents of rotation. I broke this specific objective. I put them into some small concepts, okay? Rotation of 40 of rigid bodies. Okay, rigid body or rigid bodies. I will teach you first here what it is of a rigid body. Okay, so we can call it because it's just like the 6 subtopic, the 6th topic in mechanics, so 6.1. I will teach you the concept. We call it in rotation, introduction of what? Rotation. I'll give you the introduction, the foundation, rotation of what? Of a rigid body. Of a rigid body. Right? Rigid body. Then the next subtopic, I will teach you about moment of inertia. Moment of inertia. Say it before we start even to learn it. Moment of inertia. 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 Okay? The next concept that I will teach you, about radius of gyration. Radius of what? Of gyration. Radius of gyration of what? Of rigid bodies. Radius of gyration of rigid bodies. Radius of gyration of rigid bodies. Say it again. Radius of gyration of rigid bodies. Radius of gyration of rigid bodies. Radius of gyrations of rigid bodies. Radius of gyration of rigid bodies. And next the concept 6.4. I will teach you how to derive derivations. We'll do the derivation together. I will teach you the derivation of what? Of moment of inertia. Right? Moment of inertia. Derivations of moment of inertia. Moment of inertia. Moment of inertia. Our best friend called the moment of inertia of rigid bodies. Of rigid bodies. Of rigid bodies. Of rigid bodies. Of rigid, of different rigid bodies. Of different, I forgot the word different there. It's an adjective. Of different rigid bodies. Different rigid bodies. Right? That there is our next subtopic. Then 6.5, I'll teach you how to derive the derivation of what? Of radius of gyration, radius of gyration, radius of gyrations of different radius of gyration of different rigid bodies. The beauty of physics, rigid bodies. Then the next subtopic, I will teach you 6.6. This I call it, I will teach about parallel axis theorem. Say it with me. Parallel axis theorem. There's a theorem in rotational dynamics. We call it a parallel axis theorem. Very beautiful theorem. And then 6.7, I will teach you about perpendicular. Say perpendicular axis theorem. Perpendicular axis theorem. Okay? Perpendicular axis theorem. And then 6.8, I will teach you about the concepts of Newtons. We'll find again our beloved physicists called the Newtons. Newton's what? Newton's laws of what? Of rotational dynamics. Of rotational dynamics or rotational motion. Newton's law will find again Sir Isaac Newton developed the theory fundamental equation to guide rotational motion. So Newton's law of rotational motion. And then the next concept, which is 6.9, I will teach you about it. The next concept is called the torque of rotating rigid body. I will teach you the torque, because here in rotation, in force, we have in linear translational motion, we have what? We have something called the force. Here we have something called the torque. Okay, torque of rotating. So I'll teach about torque of rotating what? Rotating bodies. Rigid bodies. Rigid bodies. Okay? Rigid bodies. And then we go for 6.10. 6.10, we say that I will teach you the concepts of angular momentum. Do you remember that one specific objective is asking us to cover this? Yes, angular momentum. Then 6.11, I will teach you the concepts of rolling cylinder on an inclined plane. What if we are rolling a cylinder? Say a cylinder. So a cylinder is one of example of the rigid body. A cylinder, right? Rolling a cylinder on inclined plane. When you say inclined plane, like those that I told you, Newton's law, inclined plane. Inclined plane. Okay? And then the next concept, I'm about to finish to present the concept that we are going to cover. And stay tuned. Make sure that you revise this video several times as you can, because it's powerful and it will change your life. You'll never forget the rotation you learn for the rest of your life. Okay. Then we go to the 6.12. Problem 1-2. We say that I will teach you the concepts of rolling what? Now, not a cylinder. The shape now has changed. We're going to change it. Rolling a sphere, means rolling sphere on an inclined plane. On an inclined plane. On an inclined plane. On an inclined plane. Like the one that I told you in Newton's law. Okay? Then the next concept now, I will teach you kinetic energy, how we can derive the formula of kinetic energy, because this is rotational motion. Kinetic energy, right? Kinetic energy of what? Kinetic energy of a rotating rigid body. Of a rotating rigid, right? A rotating rigid body. Okay. Then we go 6.14. Okay. Next is our topic now. Hey, this is fantastic now. Work done by a torque. I will teach you how to determine work done. Work done by by torque. Torque is a force in rotational system. Okay, by torque. By torque of rotating or acting to the rotating rigid body. Acting to the rotating torque that acting to the rotating rigid body, right? Rigid bodies. And then the last thing, good news, you have been waiting this last thing. Okay, 6.15. I will teach you now problem solving, right? Problem solving. We are going to solve problem solving relating to what? Relating to rotation or rotation dynamics or rotation of rigid body. You know that the technique I've been given to teach you this topic. I will be teaching you concept first, all the concepts, and then at the end we're gonna solve problems. However, that I might change along the way. But according to the way that I prepare and teach you concepts, depend. I can change. Okay, depends. Don't get like that. I can change because I can swap the questions, take the questions, and then plug them in different those sub concepts or in those concepts. Okay, so these are the contents that you have or we are going to cover along our program of learning rotation of rigid body. I believe that you had a very good moment on these contents. So my presentation is, even if that you decide that you say, no, I cannot continue with Olenjolai's program, it's fine. But I told you the truth. Wherever you go, make sure that you learn these contents. I'm not jealous, right? I understand there are many A-level teachers who can assist you, right? And I like them, and I respect their presence. So now let us go to the business. This is now, we are going to start the first concept, 6.1, we call the introductions of what? Introductions of rotation. In case you have any question concerning about what I'm teaching, please use the platform of the comment section there, ask your question. As a student, the world can answer, or in Tanzania, can answer in other different regions, or even myself, I can answer your questions. So don't hesitate yourself asking questions because it's maybe it's a digital program. No. In digital, you can interact and ask, and the students can ask many questions even more than in the physical class. You know why? Because you are going to ask a teacher who is not seeing you. In physical classes, sometimes if you be asking many questions in the class and the teacher is not well prepared, you know what happens? It means that he or she is going to hurt you because you are disturbing him. See? But digitally, the teacher is noticing the student. So you're not shameless. Even sometimes that that you are afraid to ask a question in the class because you are afraid with the surrounding, you don't have confidence. Okay? But in digital, you will be alone. You will ask the questions. Okay? So, introductions of rotation of rigid bodies. Okay? Of rigid bodies. In this part of introductions of rotation of the rigid bodies, I'm going to introduce to you some of important concepts. And you'll be basically to understand the concepts of motion or of rotation dynamics. So, the first thing that I want to excite you is we say that types of motion, right? Types of motion based on what? Based on types of motion, because yes, we have different types of motions. Types of motion in mechanical system. In mechanical system, we have different types of motions in mechanical system, right? Mechanical systems, and this we have many types. Okay, so we say that there are different types of what? Of motion in mechanical system. In mechanical systems, okay, some of these types are, the first one, we have the motion called the translational. Say translational motion. Again, the second type is the one that you are learning now, rotational motion. Right? Rotational motion. Then the third one, the one that we covered before, or we are covering also, is all about circular motion. And then we can have also, we have projected motion. And also we have another one we call the simple harmonic motion. So you see that we have many. But our target in this case is on these first two types of motions. Okay? Good. And then we are going now. So now the types of motion. And because you know the types of the motion, then now we can learn the main two types of motion that we have in daily life. Right? So that's the case. Right? Okay. So then If that's the case, we say that let us start now with first the translational motion. Say translational motion or translatory motion, some of the book. Translational motion. Translational motion. And the fundamental question that I would like just question number one. What is, ask yourself, pause the video, ask yourself this question. What is translational motion? Translational or translational? Translational. So this is translational motion. So we may do minor correction. Okay, or translator motion. So translational motion. Translational motion. What is translational? Translational what? Translational motion. Right? So we say that some of the differences that different definition, but we say that this is a motion, right? Is a motion in which all points, okay? All points of a moving body, all points of moving body, right? All points of moving body move uniformly. Say uniformly. I told you in circular the difference between uniformly and non-uniform. Move uniformly, it means that with constant speed, right? At the means of uniform, constant velocity, in the same line. Or in the same direction. That's the meaning of translational motion. Translational motion is a motion in which all points, not one point, all points of what? Of a moving body move uniformly with constant velocity in the same line or in the same direction. So what does it mean? Suppose that I am a moving body. I am a body that I want to move translationally, right? So Olenjolai have what? Different points. I have different points. I have the hands, I have the head, I have the hairs, I have the ear. You see, I have the nose, I have the mouth, I have the big ears. See, I have the breasts. You see, I have the neck. So these are the different points. So if you want to move now translationally, all the parts will move the constant speed with the same velocity, with uniform. So if I move uniform in a straight line from this point where I stand right now, and I move in this way, so all the parts are moving in a straight line. So this is what we call it translational motion, right? So we have many examples of these translational motions. Okay, we have many examples of these translational motion. You understand now. For example, most buses they might experience circular and the translational motion. You see, also we have many different bodies that experiencing what are translational motion. Okay, so cars, bicycles, right? So examples. You have many examples, right? Maybe say that motion of what? Motion of a human being, okay, can be translational. Maybe you can say that motion of what? Of animals can be translational. Of animals, motions of what? Of a car can be translational. Motions of what? Motion of a bicycle, okay, motion of bicycle, okay, motion of what? Say that motions of the bicycle, bicycle. See? And then you have different motions of the train. They move in translational, trains. Motions of aircraft. So you have many systems that are moving translationally. So you can add up more examples. The second type that we are focusing is a topic that we are learning. We call the rotational motion. what is the meaning of rotational motion? What is it? Right? So I found fantastic definition. This is the fundamental question 2. What is the meaning? So what is the meaning of what? Of rotational motion. What the means of rotational motion? Well, I found one of the definition. You can find even other one. This is the motion. Is a motion of a rigid body. Say rigid body. Is a motion of a rigid body, right? It's a motion of rigid body, which takes place in such a way that all its springs, right? All springs or its particles, springs or particles, right? All springs or particles, right? Particles move in cycle. Say cycle. So don't confuse the cycle. Move in cycles, right? In cycles about an axis, right? About an axis with a common angular, it means uniformly, okay? With a common angular motion. It's a common angular motion. So axis, an axis with a common angular motion. So listen carefully. Rotational motion is a type of motion, or is the motion of a rigid body. It's a motion of a rigid, so you have the word of a rigid body, which takes place in such a way that all its particles move in cycles about an axis with a common angular motion. So listen, it's confusing between circular and rotation. Many students, they do confuse, and even many teachers, they do confuse. Listen, suppose that Olenjolai is a rigid body. Remember that Olenjolai can move translationally, circular, and rotational. Follow along. I'll demonstrate the translation, right? Let me represent first circular. Then I will make a differentiation demonstration to differentiate with rotation. Are you ready? Okay, so let us go. So suppose that I'm at this point A, right? Then I want to move circular, in circular motion. So I'll be moving like this, right? So like this. So this is circular. So when I'll be moving, the axis of rotation is the center of of the cycle. And this cycle is measured in terms of radius, right? That is what is circular motion. Then again, consider Olenjolai. Olenjolai is a rigid body, right? Because a human being is a rigid body. Consider now we are going to the demonstration of the said motion, rotational motion. Olenjolai is a rigid body. Want to move rotationally. You know what happens? We used to apply this when we were kids. So you know what we are doing? We are moving this way. So this is what rotational motion. The axis of rotation is lying at the center of Olenjolai. See? So this is all the particles, all the bodies that consist of Olenjolai are moving in rotational motion. You see? And then if you stand, you find that you want to continue not rotating about your own axis. So the issue is, listen, for the circular bodies, they do rotate about an axis, which is what is center of the cycle. But for the rotational dynamics, bodies, the rigid bodies rotate about their own axis of rotation. So you say that in cycles about an axis with a common angular motion. So let me make just a clearance here, because you should make sure you understand the difference. Otherwise, actually, you can get lost before even going to the 10th or even before arriving the 6th or the 7th concept or the 6th subtopic. So listen, the axis of rotation, the axis of rotation of what? Of rotation. Axis of rotation of rotational motion is acting at the center of what? Of a rigid body, not the center of the cycle. Make difference of that. Center of rigidity body. Center, acting at the center of the rigid body. What does it mean? Suppose that this is the rod, because one of the examples of the rigid body is called what? A rod. Suppose that this is the rod. This is the rod. Let me draw another one. Just like the one we use, who are Maasai to drive 40 cows or sheep or goats. So this is the rod, right? So if this rod move in rotational dynamics, then the axis of rotation will be at its center. So this is what we call the axis of rotation. Again, another example of rigid body. For example, let me just give you the real life examples. You know the DVD or the CD, right? When you are playing, then what happens? First of all, there is a center there, right? And that center should be placed somewhere. So when this CD is rotating, then the axis of rotation is at the center of the CD, of the DVD. So this is the axis of rotation. So the axis of rotation for the CD is perpendicular to the surface of it. See? Again, another word, for example, we can take example of a ball, right? Similar to the ball, for those who like footballs, right? So a ball, it can rotate about its own axis. So for example, that a certain player is winning maybe a goal, then you find even the balls, if you look, it's rotating about its own axis. A ball cannot describe a circular. A ball is rotating about its own axis. That is rotational motion. If it is circular, listen carefully. If example that this rod is moving circular or this disc is moving circular, you know what happens? So this, you should have a cycle first. And then this disc now, or a ball, then it should be a part of this pass. So you find that this one now should have tangential velocity. And then here, the axis of rotation is a center because you have radius. So suppose that this is figure A, and this is figure B, and this is figure C. You see? So now this is the same disc but describing what is circular motion. Don't think that rigid bodies experience only rotational motion. They might experience translational, they might experience rotational, they might experience circular motion depending on the situation. So this is part C. So then remember that this one and this part and these dotted lines, these are the one that we call axis of what? Axis of rotation. Axis of rotation of what? Of rigid body. I believe that you enjoy the beauty of physics. Tell me in the comment sections if you've understood it yet. So now, I believe that I've omitted the complication between the three types of what. I can't define the meaning of circular motion because I told you the definition of circular motion in the topic you call the uniform circular motion. Okay, so review also those materials because they're very important. Okay, so after teaching you rotational motion or those types of motions, what are the examples, right? Okay, what are the examples of rotational motion? So examples of what? Of rigid bodies, right? Rigid bodies experiencing what is rotational motion. And I will give you the real life examples, because physics is the study of nature, rotational motion. I have few of them, but there are thousands. Okay? The first one, rotations of the wheel. Rotation of motion. Rotation of what? Rotation of the wheel. When you say rotation of the wheel or rotation of the tire, if the word wheel is a vocabulary for you, specific term or rotations of the tire, we have many vehicles. We have a car. So it's when the car is moving in linear motion, then the wheels or its wheels or its tires, they rotate about their own axis. You see? So you don't understand. So the car can experience. Listen, let me just make you just let's surprise you. A car is one of the rigid body that can experience 3 types of motion. A car can move linearly at the same time the tires or the wheels rotate, and even some other parts of the car. But when it reaches the roundabout, listen carefully. When it reaches the roundabout, at the same time, you find that now the car is no longer experiencing translational motion. It's experiencing what is circular motion, but the tires are still experiencing what is rotational motion. Fantastic. Have you ever discovered that? And if you have that kind of discovery, believe me, you are going to solve real world problems, and complex one, because that's why we are preparing you. So rotation of the wheel or tire of the car, of the motorcycle, of the bicycle, of any, maybe, of airplane. You see, anything or any we call that just things that have motors. Rotations of the rotor of the motor. You see, the second example, rotation of. Okay, so I give you promise that I give you real life examples. Rotation of a DVD, right? A DVD, whether in DVD player, whether in computer or CD. So you used to listen to songs, used to watch the movies on the CDs or the DVDs, but you didn't realize that this is rotational motion. So today we're introducing to you that when you cover mechanics and you cover rotational motion, you have to come up with an idea. How can you design a body that can rotate or can solve a particular problem that's rotating about its own axis? The second example is rotation of what? Rotation of a ball. Now, those lovers of football, we are with you right now. Rotation of the ball. When the ball is being played. If you're experiencing, you're watching the game for the 90 minutes, you'll find that the balls, in many cases, the ball is rotating. But you've never experienced, you're just celebrating that we won. We kicked the Barcelona, we kicked the maybe Man U, and we kicked the maybe a certain team. But you don't know that ball is experiencing rotational motion. Fantastic. Okay. And then the first example of rotational motion, rotation of the cylinder. You say rotation of the cylinder. If you study rotations of the cylinder, if after A-level studies, you study mechanical engineering, then you learn rotations of many cylinders, rotation of the cylinders, because you have hydraulic system, and then in the hydraulic system, we have something called the cylinder. Even in the vehicle systems, in the aircraft, if you study about the aircraft engineering, you'll find those rotations of the cylinder. Again, we have another example, rotation of spheres. Okay, rotations of spheres, or bodies which are spherical. The good example of the spherical body, or the body which is starting the sphere, is the S. The S rotates about its own axis in how many hours? 24 hours. So that is rotational, right? Not revolution. Not revolution. I'm confused. So I think that we can even add example 60, example 7, because rotation is beautiful. Then, if that's the case now, you know the difference of translation, you know the meanings of rotational motion, circular motion, and translational motion. Allow me now to take you into another concept. We call it a rigid body. What is a rigid body? And the question I want to ask you, pause the video for a minute, and then ask yourself, we've been hearing rigid body. What is it? So that's the fundamental question. What is rigid body? So the question is, what is rigid body? What is rigid body? Right? A rigid body. A rigid body is a rigid body. Is impure. We say that a rigid body in pure rotational motion. A rigid body in pure, not impure, pure rotational motion. Pure rotational motion, right? Pure rotational motion. We say that we can define that a rigid body in pure rotational motion, whereby all particles in the body rotate through the same angles. So we say that is a body, a rigid body is a body in which all its particles, right? All its particles rotate through the same angle, through the same angle, right? Through the same angle, okay? During the same time interval. 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 So you say that is a body in which all its particles rotate through the same angle during the same time interval. By the means of rigid body. Again, let me clarify. A rigid body is in pure rotational motion, is a body in which all its particles, be serious please, all its salty particles rotate through the same angle during the same time interval. So what they mean? This ruler contains many particles, right? For myself, the rigid body, I told you that, contain many particles, right? But if I will be rotating like this way, I'll be rotating about my own axis of rotation, and then through the same angle, right? At the same time intervals, then that's why that I'm called a rigid body. So there are rigid bodies and non-rigid bodies. So I will give you examples of rigid bodies, and your homework is go and find non-rigid bodies because they are there. And you love physics. And before even I give you examples, let me first give you examples of rigid body, and then I will tell you something that God insisted me to tell you before, because you'll find this concept in later lectures. But I want just to excite you because I should build a strong foundation. So what I'm doing today, I'm building a strong foundation in your mind. Because if you build a foundation, now building the house above the foundations is simple. So then we say examples. Examples of rigid bodies. Okay, if you've understood the definition and everything that I've been teaching from the beginning, you can pause and ask yourself, what are the examples now of rigid bodies? I've already mentioned. They're already in your mind. They're already in your hands. Okay? So the first example, a human being. And if you say that you are not a rigid body, but myself who is teaching you Olenjolai is a good example of rigid body. I'm a rigid body. Okay? Then the second example, a ball. The third example, a cylinder. Right? The first example, a sphere. A solid sphere. Solid sphere. Okay? The fifth example, a car. A car is a rigid body. Okay? A ruler. So you have many different examples. But again here, I want to add up one of a rod. So for example, number 6, you have a rod. And then something new, maybe in your mind, you don't know a rotor of a motor. So a rotor. So you know, motor used to rotate about the axis. Have you ever seen motors working, pumping water at all? Have you ever seen them? If you open, then you find the motor is experiencing what? Rotational motion. And the part that is experiencing rotational motion is called the rotor of a motor. Because I know some of you will pursue the courses in undergraduate studies or bachelor levels of engineering. And I would like just to congratulate you. And possibly you don't know that. The teacher who is teaching you, he's also blessed by God to be an engineer. Right? So when it comes to the sum of engineering, especially that for electrical engineering, you get surprised again. Because I want to impact the nations and I want to create a special generation to solve complex problems for our own nation. Okay, so those are the examples. So you can add up number 8, number 9, etc. So now I want, before even I got the next part now, which is all about moment of inertia, I want to speak with football lovers. And I want to link what they used to see at the stadium, or in the stadium, with rotation, right? Because I know they like watching football. Every week, at least one day, you go to the video show to watch the ball. Good. That's your talent. That is what we call it your favorite, right? That's what you like. It's fine. But connect with mechanics. You know, for example, if a back and a player in the field, for example, just mean that if in case that he is kicking the ball, you know what happens to the ball? Sometimes depends on the way or angle of kicking the ball, but the ball is the one of the body that can experience two types of motion at the same time. You know which motion? A ball can rotate about its own axis at the same time is also experiencing translation. Because later on in this topic, we'll be learning the system, for example, rolling of the cylinder in an inclined plane. So the cylinder will experience in both motion, translational and rotational motion. Rolling of the sphere in the inclined plane, it means the sphere will experience in both rotational and translational motion. Okay? Okay, so that is good. So then now, let me take you and introduce to you another part. I'm about to end this lecture soon, so don't get tired, don't get bored. So now to end this lecture, I want to do something. Now, I want to take you into the heart, say heart. The heart of rotational of the topic of rotation of rigid body is the concept we call it moment of inertia. Moment of inertia. Say moment of inertia. In this one, we have notations of I. So this is the heart. We'll be mentioning moment of inertia possibly throughout the topic. So you will hear this word. So in case you heard it, I would like just to say sorry. Excuse me, sir. Excuse me, madam. You don't have an option. If you want to master rotational of the rigid bodies, then moment of inertia should be your friend. Okay? Good. I see some of my students there, they are dancing, they're enjoying the beauty of physics. That is good. So the question, this will be question number 4, right? What is, or define, what is moment of inertia? What is moment of inertia? Ask yourself. Pause the video and ask yourself. Moment of inertia, I believe that's not a new terminology for you. During your O-level studies, you had introductions in motion of the straight line. And even in Newton's law, as one of the topic of mechanics, also we introduced to you the concept called inertia, especially in the first Newton law of linear motion. So inertia still have the same meaning, but here we might define in different ways. But in case of linear motions, the mass is the one that can resist motion. But in rotational now, the inertia is the one that is resisting the motion. Well enough. So let us go to the business. What is moment of inertia? A form to definition I will present to you. It's a moment of inertia. In rotational dynamics, moment of inertia, right? Moment of inertia. We say that is a quantity. Is a quantity that determines the top needed for desired angular acceleration. Angular acceleration. Okay? Desired angular acceleration about a rotational axis. Rotational axis. So that is the first definition. Let me give you the second definition, and I will discuss both of them, and then we'll see the beauty of physics and how physics is sweet. Okay? I found three. I will give you all the three. Oh, some of the references say that moment of inertia is a sum. So this is the sum. Sum of what? Of the product. Sum of the product. Right? Sum of the product of the composite. Right? Mass. Composite mass. The composite mass and the square. Fantastic definition. And the square of respective distance and the square of the respective distance, right? From the axis of rotation. From the axis of rotation. That's how we define moment of inertia. Mathematically, according to this definition, the source also gave us the mathematical definition. At the moment of inertia, this one is equal to summation from I is equal to 1 to I is equal to n. Then mass I times Ri then square. So that's the formula. However, that we'll discuss it later. Let me write it here clearly. Maybe you didn't see it. So you are saying that, you know that the format has been written at the end of the column. So you say that moment of inertia, mathematically, it's a moment of inertia, this definition, is a sum of what? Is a sum of all composite masses from I is equal to 1 to I is equal to n. Then here we have a product of mass times what? Square of the distance from the axis of rotation to its ends. Right? So this is a very important mathematical definition which we have already introduced it to you. However, that will come back later. Some of the resources define moment of inertia in this way. this way, which way? Find this way. Moment of inertia is the resistance of the rigid body to change the angular velocity when the external force moment of inertia is a resistance. Is a resistance of a rigid body to change okay, its angular velocity. Its angular velocity. Its angular velocity when external torque. When external torque is applied on the body. So we have the definition of moment of inertia. And let me spend a few minutes to explain what does they mean. Right? You may choose one, any of them. That's why I gave you enough. Because in this program, I will never teach you to cram. Myself, I fail to cram. So I don't know how to teach the students to cram concepts. I will teach you to understand. Moment of inertia is a quantity. It's one of the physical quantity that determines the torque. Say torque. Okay? Needed for desired angular acceleration. For desired angular acceleration about a rotational axis. So it's what determines the torque needed to desire for desired angular acceleration about rotational axis. And I told you what the means of rotational axis is always at the center, as perpendicular to the surface of the body. Or some of the references say moment of inertia is a sum of what? Of the product of what? Of the composite mass and the square of what? Of the respective distances from the axis of rotation. And that's why that we have this formula. Right? I'll come back to this formula soon. Or some sources say that moment of inertia is the resistance of what? Of a rigid body to what? To change its angular velocity when external torque is applied. For example, in case of motion, linear motion, translational motion, what does resist the change of the motion? Mass. So in rotational dynamics, it's inertia. For example, that I want it to evolve, maybe with a very high angular velocity, right? But I fail because of the inertia that I have. It's not similar that if, for example, that there's a CD, I cannot rotate myself like that at the speed, at angular velocity of the CD or of the DVD. Fantastic. Physics is beautiful. So now, mathematically now, oh no, even this man also defined, gave the mathematical formula. Mathematically, moment of inertia, according to also this definition, moment of inertia is given as what? Integral of what? Of mass times what? Square of the distance from this axis of rotation. So this is mathematical formula. Right? That is mathematical formula. So this is integral sign. So we say that the moment of inertia is denoted by what? By the symbol I. capital I. The symbol capital I is the notation for T for the moment of inertia. Okay, good. Remember that advantage of this digital program, you can repeat this, watching this video and learning through this video several times as you can. It's quite different from the physical programs, I call it analog programs. When you hear it once, yes, you understood, you won't hear any sound of the teacher that teaching you. But fantastically, this one, you can repeat it at any time. And make sure that you use these materials to help you understand the concept. So mathematically now, we have this mathematical formula, and you have this mathematical formula. So you say that simply the mathematical formula, right? The mathematical formula of what? Of the moment of inertia is given as this. Because you know, this is algebra notation, sigma notation. This is, we call it calculus. You know that I'm also a teacher of mathematics. I thank God for his blessing. So I understand what I'm writing here. Possibly yourself is the new song, but don't worry, I will help you to understand even more than I do. It's my intention. I want to see all my students are more successful to me. They should be successful in real life, not only in passing and having certificate. I'm not teaching you in order to get something called a certificate. I know you will get a certificate, but your focus should not get a certificate. Your main focus should be solving real life problems. That's why you went into school. But unfortunately nowadays, because of the politicians and the different reasons, you find students that are suffering on looking for certificates rather than knowledge. So we are killing ourselves. So we think we are being trained to be employed rather than to deploy yourself. It's a disaster. And the world is changing. Okay, it's given as what? Moment of inertia is equal to mass times 40 square of 40 of distance from the axis of rotation. So let me demonstrate the meaning of this formula by using a diagram. Suppose that this is the disk, and then this disk is rotating. So because this is two-dimensional, the blackboard is two-dimensional. So it means that you say that suppose that the axis of rotation of this disk is this. So this is what we call the axis of rotation, right? Axis of rotation. So it's revolving or rotating like this way. So listen carefully. This is the disk, for example. This is the center. So from this center, we have a distance from this center to the circumference. The distance from the axis of rotation to the circumference, this is what we call the R. R is not radius because you have different shapes. You can have a rod. Even if that you can have a rod. So a rod, you will think that a rod has radius. No. So a rod, if it will be rotates about its own axis like this way, then you have the distance from the axis of rotations to the point where mass is highly concentrated. So it means that this is the point that we find high concentrations of the mass of a body. Therefore, the CD, you find that the inner part is empty, so its mass is concentrated along this, right? So that's why that we say that in order to get the moment of inertia, the resistance of this body to rotate, then you say we take mass of the rigid body, we multiply with the square of the distance from its axis of rotation to the point where mass is concentrated. That's why that simply, for you, at this time, we introduce you that this is the general formula of what? Moment of inertia. So moment of inertia providing what? Providing resistance. Again, to remind you, we can also find dimensional of moment of inertia. I taught you in what? The topic of dimensional analysis. So the dimension of inertia, it means that you apply dimension to both sides. So these are the dimensions of mass. Then here we have dimensions of the square of the distance, right? Also the dimensions of the distance, but it is squared. Then dimension of moment of inertia, my lovely student, then we say that this is what? Mass, right? Mass power 1. And then this is radius. So it's a distance. So this is L square, and then the period 0. So the dimension of moment of inertia, in case you find these questions in dimensional analysis, is given by what? Dimension or mass are 1, length square, and period or 0. So this is the dimension. Remember also one of the applications of dimension, we say that we can deduce the SI unit of 40 or the physical quantity. So what the SI unit here now of the moment of inertia? Simple. The SI unit of mass is what? Kilogram. The SI unit of length is what? Meter. So the SI unit of what? Of moment of inertia I is what? Kilogram meter square. Okay. Beautiful, 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 beautiful. Physics is beautiful. Physics is beautiful, beautiful. Then again, I'm still introducing to you build the foundation of moment of inertia, because I told this moment of inertia, it's the heart of rotational of the rigid body. If you know the moment of inertia, you have gone some distance. Again, in introductions of moment of inertia, I have again another point that I want to make. And the point is saying that moment of inertia that exists in the body to rotate in or to move in a rotational motion, moment of inertia of what? Of rigid body. Of rigid body, right? Moment of inertia of rigid body. Rigid body, we say that of the rigid body about its own axis. About its own axis depends on the following quantities. Depends on number one, first of all, from the formula, depends on the mass of the body. You see? So if the mass of the body is large, then the moment of inertia also is large. So they are very proportional. So the first factor is what? Mass of rigid body. Mass of rigid body. Then the second parameter, distance from the axis of rotation, which is R. So for this case, from the formula there is M. And then we say that the distance from what? From the axis of rotation, right? From the axis of rotation, okay, to the point where mass is concentrated. Then the steady factor that can affect it, the moment of inertia, the way that the mass of the particles distributed. Okay, that's another factor. So then this factor just will deduce them from this formula. So you find that first of all, moment of inertia, their portion of the mass of the body. Secondly, moment of inertia is their portion of the square of the distance from the axis of rotation, the point whereby mass is highly distributed. Right? So if you increase the mass, you increase the moment of inertia. If you increase the square of the distance from the axis of rotation to the point where the mass is being concentrated, then you increase what? Inertia. If you reduce the mass, reduce the inertia. If you reduce the square of the distance, you reduce what? The inertia. Okay? In case you have any question, don't hesitate yourself. Ask your questions, in the comment section. Okay? Comment sections. Because I want you to understand the concept of rotational the reading board. So, this is a good time for the students. I know I've been teaching students before I began this digital platform or digital program. I used to teach students analogy. It means that physically, and I know their mindset. I know they are always very happy if they hear a word from the teacher that this is the end of the session or the end of the topic, even if they didn't understand anything. But they are very happy because of the different reasons they develop as the students. So even we ourselves, in some circumstances, we are sometimes happy because that sometimes you might find that the teacher who is talking there is boring. Sometimes it may happen that you are very angry. Sometimes that you didn't sleep last night. So there are many factors that making students to celebrate at the end of the topic or at the end of the lecture. So I would like just to say that this is the end of the lecture 1 or session 1 or period 1 of rotation of rigid board. Firstly and frankly speaking and publicly declare, I thank God who have prepared me to teach this material. They are very complex, their nature, but God simplified them in my mind and I've tried my level best to share. This is not the end of learning. Ask your questions in the comment sections. Ask that I didn't understand a certain point. If you find that maybe I've been teaching quickly or fast, you can pause the video. You can repeat it several times. Nobody who is limiting you. In case that you missed the classes, maybe you are sick, you are whatever, I can take these classes at advantage for you. In case that you are absent from the school, any factor that is encountering you, so you are learning now is already solved with this online schools called Tanzania Online A-Level Secondary Schools. So please make sure that you tell us you are enjoying these materials from which schools, from which region, right? From which continent, from which country. Tell us in the comment section. From which street, from which city. Tell us. We want to know where if we reach with this program. Ask your questions. Answer questions. Also, some other students will ask in the comment section because comment sections, I made them public. Every student can see. Every teacher in the world can see. Right? And then another thing is, don't ignore your ordinary physical learning because of this program. So don't dishonor your teachers. Right? Because you know that some they say that, Olenjolai is finished. Olenjolai has finished everything that. So my ordinary teacher has not any help. No. Remember that I don't know everything. I share to you what I know. And also some other teachers might be good in some of the concepts that are not good. Right? Again, make sure that you subscribe onto this channel to get notification. Make sure you share these materials. In case, again, because you know always that when you reach the end of something, then you'll find that you enjoy, you have been happy, and even you have a heart of thanksgiving. In case that you feel from your heart that you want to offer a thanksgiving, free-willing thanksgiving, in order to afford the running cost of this program. It's very expensive. God has asked me to make this program free of charge. You don't pay anything to me. But he asked me to invite you for anybody, for any amount, from your heart. Just like myself, I'm not forced. I'm doing this program for my heart. So I have peace of mind. I cannot complain. I experience many challenges. I spend a lot of money of myself. But I know that I'm investing in the mind of restrictive people for our generations and even the future generations. God always make a return if you offer. So in case that you have your free willing thanksgiving, doors are open. Then send them this telephone number. The names, the registered name or confirmation name is Olenjolai. That's my name. In case also you want to send your thanksgiving offerings, where is the bank transaction, go to the descriptions of this video, and then I will get the account number and account name and everything so that you can do that. In case you want to order materials, because also I used to sell online textbooks for advanced level. I used to send the questions and answers. I used to send the syllabus book. So I have a lot of materials and even the notes that you can order them online, and I can ship at your regions or at your place by using the modes of the transport, which is by using the buses, which are regional buses for United Republic of Tanzania. If you are enjoying this program from Zanzibar, from Pemba, don't worry. I can use the boats, which are actually crossing the Indian Oceans to your place. So I want you to be quickly, and this is the time for you to enjoy and break the concepts of mathematics and science to change the world where we are living right now. So thank you very much for your time. This is Olenjolai. I love you so much. May God bless you. May God bless you again and again. I'm praying for you. Pray for me. See you in the next lecture.